Hi, we are take this question 9, which is basically this question. In the question, the vapor pressure data are given below for the system at Z of 10. A. Using a raw flow, calculate and plot the SY data at a total pressure of 101.32 kPa. B. Plot the boiling point diagram TXY graph. C. What will be the relative amount of liquid vapor phase for a mixture containing 0.45 mole fraction of hexane at 100 degrees Celsius? This is the data given from the question, so we continue to calculate using a rough flow. Now we let n hexane be A, n of 10 be B, and PA is the partial pressure of n hexane, PB is the partial pressure of n of 10. By using a rough law, PA is equal to PV vapor A XA, PB is equal to P vapor B XB, which at the same time SB is equal to 1 minus XA. So by substitution, we substitute the PA and PB into the P total pressure, which we will get this equation. So we rearrange it, we will get P total pressure equal to P vapor A minus P vapor B multiplied with XA plus P vapor B. So we rearrange it with the subject XA. PT is minus PVPA B divide PVPA minus PVPB, and YAPT is equal to XAPVPA. So for YA, we'll get this formula. By using these two formula at 68.7 degrees Celsius, we substitute all the information from the table. We'll get XA equal to 1, YA equal to 1. And we use the same formula for the following data. We'll get the data XA and YA in this table.
And now we will have to plot the x and y data at a total pressure of 100.32 kilopascal using the data we have calculated previously. And this would be the data, the graph, where x is the mole of N-hexane in liquid and y is the mole of N-hexane in vapor. Nextly, we will need to plot the boiling point diagram, T, X, Y graph, where T is the temperature, and X is the mole of N-hexane in liquid phase, and Y is the mole of N-hexane in vapor phase. This would be the given graph, where this is the temperature, and this is also the mole fraction of N-hexane in liquid and in vapor. This would be the Tx graph, and this would be the Ty graph. Nextly, we would have to find the relative amounts of liquid and vapor phase for a mixture containing 0.45 mole fraction of N-hexane at 100 degrees Celsius. To do that, we would have to interpolate the data at 100 degrees Celsius and also at 0.45 mole fraction of hexane. After doing that, we will get the point here, and we would have to extrapolate the value to the Tx graph to find the liquid phase, and also to the Ty graph to find the vapor phase. After doing that, the values that we'll get is x equals to 0.29 and also y equals to 0.675.
Hi, so we are given question 12 to find the compositions of the outlet of mixture of flash separation. So from the question, we are given the compositions of the initial inlet of the mixture, which is x1 equal to 0.2 and x2 equal to 0.8 and a12 equal to 0.0995 and a21 equal to 0.247. So before we have to find the compositions of the mixture of outlet, we have to use our activity coefficient, which is from the Wilson model. So it sub everything inside the formula of the Wilson, and we can find the activity coefficient, which is equal to, for component 1, which is equal to 3.768, and component 2, which is equal to 1.162. So after we get the activity coefficient, we can use the modified Raoult's law to find the liquid compositions of the outlet, which is P equal to x1 activity coefficient 1 and P1 saturation plus 1 minus x1 activity coefficient 2 and P2 saturation, and substitute everything inside. We can get the compositions of the liquid of the outlet is for component 1 is 0.139, and since x1 and x2 equal to 1, so liquid compositions of component 2 is 1 minus 0.139 equal to 0.861. So to find the vapor compositions of the outlet, we have to use the K ratio. Since K ratio is equal to Y1 over X1. So before we can find Y1, we have to substitute everything inside the K formula, which is Ki equal to activity coefficient I, Pi, saturation over total pressure. So sub everything, we can get the K ratio for component 1. Then we can get vapor compositions for component 1, which is 0.441. And since y1 and y2 equal to 1, so y2 will be 1 minus 0.441, which is equal to 0.559.
So to answer question A, which is to find the fraction of the feed vaporized, we'll use this formula. E equals to V over F equals to Xi minus Zi over Xi minus Yi. The derivation of this formula can be seen at the second page. We let F equals to the total number of moles of the feed stream, and V2 equals to the total number of moles of the vapor product, and L equals to the total number of moles of the liquid products. In terms of the mass balance, we will get F equals to L plus V, which is the first equation. In terms of the material balance of the species I, we will get the second equation. Substitute the first equation into the second equation, we will get the third equation. After rearranging the equations and we let E equals to V over F, we will get the fourth equation. Dividing the fourth equation by Xi, we will get the fifth equation, while we let Ki equals to Yi over Xi. The Ki here refers to the K ratios of the species I. After rearranging the equation and we make E equals to the subject, we will get the sixth equation. E equals to Xi minus Zi over Xi minus Yi. So we come back here. Using the answer from the previous calculations, and we substitute Xi equals to 0.139 and Zi equals to 0.2 and Y equals to 0.441, we get E equals to 0.202, which is the fraction of the feed vaporized.